In example 5, we're asked to determine whether a matrix is in row-echelon form, reduced, and if it's in row-echelon form, to tell whether it's in reduced row-echelon form or not. Before being able to tell whether a matrix is in row-echelon form or reduced row-echelon form, we better learn what those are. So why are we learning about those forms? Because when we solve systems of equations using matrices, we either put our matrices in row-echelon form or reduced row-echelon form. So we should know what those are. We're going to now look at the definitions in the book, so we're able to identify which matrix is in row-echelon form and which one is in reduced echelon form. So let's take a look. Any row consisting entirely of zeros occurs at the bottom. Okay, so occurs at the bottom of the matrix. For each row that does not consist entirely of zeros, the first entry, the first non-zero in the entry, should be a 1. Then 3, for 2 successive rows, the leading one in the higher row should be to the left of the leading row in the lower, to the leading one in the lower row. Then, so first we're going to just be concerned about row-echelon form, then we're going to talk whether a matrix is in a reduced row-echelon form or not. So let's take a look. We have 7 examples. A. The first entry in each, the first non-zero entry in each row is a 1. Each 1 is to the right of the 1 in the upper row. So the matrix in A is in row echelon form. B. What's the problem here? Where do you see the zeros? You see the zeros in the second row. Where are the zeros supposed to be? At the bottom. So the matrix is not in row echelon form. Row of zeros is not at the bottom. Okay. C. Every single row looks exactly as it's supposed to look. The first entry, the leading entry that is not a 0, is a 1, and the ones in each row are to the right of the ones in the previous row. So this is in row echelon form. Let me get a better marker. We continue. D. 1, 1, 1 is the first entry, the first non-zero entry in each row, and the one in row 2 is to the right of the one in row 1, and the one in row 3 is to the right of the one in row 2, and finally the bottom row consists entirely of zeros. So this is definitely in row echelon form. Let's move on to E. We got a problem with E. This is not in row echelon form. Why not? Let's take a look at row 2. There's a problem in row 2. 0, 2. the first non-zero entry should be a 1, not a 2. So A22 should be a 1. So not row echelon form. Okay, let's continue. Next one. Are we good? Yes. In each row, the first non-zero entry is a 1. The 1 in row 2 is to the right of the 1 in row 3. The last row consists entirely of 0. So this is row echelon form. Let's take a look at the last one. This example is not in your book. Actually, just put the example there. There's a problem with row 2 and row 3. So row 2 and row 3 are the problem. Can you see what the problem is? Let's see. The first non-zero entry in row 2 is a 1. The first non-zero entry in row 3 is also a 1. What's the problem? The 1 in row 3 is to the right of the 1 in row 2. That's not supposed to happen. And so, for G, one of the rules, one of the conditions in the definition is not satisfied. So this is not row echelon form. Not row echelon form. Let's quickly look at the definition for reduced row echelon form. So you notice that if a matrix is in reduced row echelon form, there's one additional condition, which is every entry above and below the 1 should also be a 0. And so, let's see. A. We look at the 1 in row 2, and what do we see above it? We see A2. What's supposed to be there? A 0. So, not RREF. RREF means reduced row echelon form because, well, there's two problems, but this is a 2. It's not supposed to be a 2. It's supposed to be a 0. And this one should also be a 0. So, had those two been zeros, the matrix would be in reduced row echelon form. So, because A1, 2, the element in row 1, column 2, does not equal 0, and the element in row 3, column 3, that's not the problem, I'm sorry. Wrong problem, this element. So, and A1, 3 is not a 0. We do want this to be a 1 because we want the first non-zero element to be a 1, but we want everything above it to be a 0. Okay? I'm not going to go into that much detail for all the problems. So this one we don't have to worry about. It's not even in row echelon form, so we don't care. B, this is in row echelon form. What is the problem? The problem again is there's a 2 here, and above this 1, there's a 3 and a negative 1. So quickly, how do we change that? This should be a 0, this should be a 0, this should be a 0, and then we'd be fine. Okay? This one is in row echelon form. We notice below this one there's only 0, above and below this one only 0, above and below this one only 0. Not only is this matrix in row echelon form, it is also in reduced row echelon form, and there's only one more. And I'm sorry about that. I'm going to skip E and G. They're not even in row echelon form. Is F in reduced row echelon form? Let's see. Below this one, only zeros. Above and below this one, zeros. So yes, it is also in reduced row echelon form. You will see as we do applications of matrices, why are we so interested in the two forms? And that's the end of example 5.